All right, we'll start. This is 3:01, so we probably gave enough time for stragglers. Today, so welcome to Introduction to Deep Learning. If you are new here, if this is your first time, we are part of the University of Arizona Data Science Institute. And if you go to our webpage, go to Data Science Institute Education, University of Arizona Data Lab, you can have a look at all these workshops we are offering. In fact, we have things like navigating the world of data engineering, geospatial science, even there is another workshop on learning the basics of Jupyter. This is data science tapas, which is a lot of mixed bag of tools. We are also offering cracking the coding interview, and this is specifically for students in jobs related to computer science, where they expect you to be cracking a bunch of typical coding interview questions. So that happens on Wednesdays, 2 to 3 p.m. And also there is a version of this happening tomorrow, Friday at 4 p.m. I haven't announced it yet. So if you guys want to join, talk to me after this class. I'll send you the link, or actually come to the same Zoom link at 4 o'clock tomorrow. So I'll just click on this, cracking the coding interview. It's basically teaching you stuff like uh, linked list and graphs and things like that, which you almost always encounter in things like LeetCode, HackerRank, Geeks for Geeks, etc. But I will be discussing a lot of specific strategy which will help you learn and not just memorize all these questions. So yeah, come to this link tomorrow, Friday at 4 p.m. So we haven't updated the websites, but this is being offered twice a week, Wednesday at 2 p.m. and Fridays 4 p.m. Then you are in this class, Introduction to Deep Learning, which is Thursdays 4 p.m., 3 to 4 p.m. And if you missed any of the previous lectures of any of the previous workshops, you can click on our YouTube channel. We upload almost all of our workshops. In fact, if you are planning to come to start with the cracking the coding interview, I would recommend you watch the first lecture on strategies, tips, and tricks. But this has been a very popular lecture, and a lot of students are telling me that it's helpful for them. So feel free to drop in. Let's go back to Introduction to Deep Learning, the workshop that you are in. So last class, we talked about the architectures. So give me a second. I lost the window already. There you go. Extremely smart. Slideshow. Interview. All right, perfect. Okay, so last week we had seen a couple of architectures that were related to the large language model. We even started training our own large language model, or in this case, it was a BERT model, which is at this point probably 5 years old. And we trained it on an independent data set, which we trained it from scratch. So why am I insisting on the trained it from scratch part? Because we were talking about these three different types of usages of transformers. One is pre-training, transferring the learning, and fine-tuning. And yeah, in the last class, what we did was pre-training, which is we are training a large language model from scratch in a particular custom data set. In this case, we had used the Microsoft Paraphrase corpus. But like I said, the LLM we used was BERT, which is pretty small and only takes a couple of minutes to train, as you saw in the last lecture. But anything after that is gonna take a long time to train unless you have any of the state-of-the-art GPUs, which, of course, not all of us have access to. So that is the reason why there is only one OpenAI and only one Google, because training a large language model from scratch requires so much huge amount of hardware resources and even time taken. Now, having said that, there is one way students of University of Arizona can have access to extremely high-end GPUs. We call it Cyvers. So if you have not been there, go to Cyvers and create an account. Don't have to do it today. We'll use it next class onwards. But create an account and make sure you use the Arizona email. Because once you get into Cyvers, you can do things like you can create, let me show you an example, right? So here, if you can go here, you can go and create an instance so that you can specify up to 128 CPU cores, up to 250 gigabytes of memory, and a disk space of 512 gigabytes. And basically all the state-of-the-art stuff. You can even request for a GPU if you want. So my point is, all the learning we do, it's not useful unless you start scaling it for big architectures and data. And we are also providing a hardware which you can access to train your big large language models, anything bigger than LLM. Also, if you have a Cyverse account, you can actually start playing with Chatur, which is a large language model bot, which we recently created for University of Arizona. You can ask questions to it like, hey, it is trained on a couple of different things. Here's a coursework, Introduction to Wildland Fire. And you can ask, so this is one course which we picked up, what is wildfire? And this is a ChatGPT equivalent we created, and it's trained on particular things. In fact, if you want to learn about Cyverse, where do I start learning about Cyverse? Let's see what it says. Please work, please work. All right, there you go. So it is helpful. It is trained on all these different things if you want to start playing with this. Anyway, coming back to our lecture. So we were talking about pre-training the large language model. Now, transferring the learning is the next thing. So what is transferring the learning? So like you said, if you have enough resources, the one I showed probably will help you train 1/2 GPT size, but that itself will take you like a couple of days. If you have resources like your OpenAI, and you already have a model trained, how can we transfer that knowledge into another task very specific to your use case? And we saw this last time, which is all these pre-trained models, including CNN, is yet another old school model which we were training. If you train it on one kind of data, it distills the data and is smart enough to understand and predict another type of data. This is called transfer learning. And we also specifically fine-tune it inside our very specific data. For example, you are a researcher where you are the only person on Earth who has access to certain rare diseases. So you have a data set. So clearly, ChatGPT doesn't know about it because it is never there on the internet, but you want to make sure it is trained on your data set. That's when you take this big model like ChatGPT and start fine-tuning it. And so that, and like I showed before, all these things, all these few things, our chatbot, like as it is very powerful, as powerful as GPT at this point, it is trained on all these very specific topics. So like this is trained on, like I said, it's this website, that website, things like that. So that is where we are trying to get to in this class, where you will have your own large language model being fine-tuned. Remember, we cannot train it. In fact, these days we cannot even fine-tune it because the sheer amount of resources needed is very high. So in Cyverse, we will teach you another technique known as retrieval augmented generation. But let me not confuse you with so much rigmarole. Let me get into what we were talking last week, like this. For example, we saw how did the transformers work. If you remember, we give the sentences to a tokenizer, the tokenizer breaks it into the individual tokens and assigns it unique values, which then are given to the models, which predicts something called logits. If you remember our task, the task was, here's a sentence, tell me is it positive or negative? And the way the transformers respond is by, hey, here are two numbers. I give 0.43 confidence for the first value and 4.6859 confidence for second value, which is positive and negative. And we saw in one of the previous classes how to transfer that into the exact percentage of confidence. And when you do that, you will see that this model is giving you 99% accuracy that this course is amazing. That sentence is positive. So the model is telling you the sentence, this course is amazing, is positive. Now, we are going to look a little bit more deeper into how these transformers work in terms of embeddings, layers, and hidden states. I know we were looking last time, we were just giving the sentence to a tokenizer, which was breaking it down into small words and giving it to a model. However, there's a lot more that happens in the background. And that's what we are going to learn about today. So today, we are going to look at multiple kinds of architectures that is inside any transformer model. So we call it encoder, decoder, sequence, et cetera, et cetera. Let's start jumping into it. So let me ask this question first. What is communication? When you speak a word and the meaning goes to somebody else, what are you doing? What exactly is communication? Verbal communication. Let me meanwhile try to see where the chat window is. Not find it. Back to meeting. Nope. Nope. All right. Can somebody, Brenda, can you keep an eye on the chat? I can't seem to find it. Where is it? Anyway, all right, not wasting time. So where is it? I don't understand. So many monitors, so I'm losing it.
Look at the
Bottom, top.
looking
Yeah, I know.
here.
Oh, there you go, finally.
You
Yes.
can open here.
All right, guys. Online, if you want to reply, that's fine too. Let me reiterate my question, which is, what is communication? What is the definition of communication?
Sharing a message.
Sharing a message. Do you want to change your answer if I tell you there are no candies today? Okay, there's an answer online, which is Pratnya says, understand words and respond accordingly. Okay. So I was kidding, I have candies, so you still get a candy. People online, that is your excuse. If you haven't learned the lesson yet, you should be here in person if you want candies, if I can find any. All right. So communication is, you all are right. Communication is you're taking a mental model or an idea, giving it into words, or essentially we are encoding your mental model into words, English words, or whatever language you speak. And that word, that encoding is the one which gets transformed into another person's head through his auditory nerves when he's listening to the words he's telling you. So in a way, what we are doing is encoding an abstract idea into words. And that's exactly what these concepts are: encoding, decoding, and sequence to sequence. Encoder-only models, so what they do is, we have an architecture called encoding. And what that model does is, we'll get into that in a second. So what that model does is takes these abstract concepts of the sentences we are giving it as input and encoding them some way so that the model understands. So just a rough introduction, there's encoder-only model, decoder-only models, encoder-decoder models, and things like that we'll see in a second. But my point is, Transformer was invented in 2017, and since then, people have been playing around with this so much. We tried encoder-only, and we had BERT, which, of course, you would have seen the names Roberta and Distilbert when we were playing with it last week. Then there is an encoder-decoder model known as BART. Then people invented a decoder-only model, which gave rise to a lot of these latest GPT versions, including ChatGPT. So, which is what I asked the question, what is encoding? Which is the communication process of encoding a mental idea into some other format. We're almost collapsing that abstract concept into some tangible thing like words and giving it to another human. Sure, that's a good thing. We know how to talk to humans. How are we all talking to computers? If talking is encoding, how do we speak computer language? What are we doing when we type something or ask the computer to open a window? Sorry? Giving it a command, but does computer understand natural language? It understands only zeros and ones. So what are we doing there? How are we converting the natural language or even like command that you want to give into zeros and ones? Yeah, how do you do that? Okay. Katie says through whatever program or operating system, you need to correct the syntax to translate human commands to machine commands. Yes. And answer I'm looking for is encoding, right? So we encode our words into bit by bit format or byte by byte format. You can use Unicode, ASCII, whatever you want. But without that encoding or a translator sitting there, you will not be able to talk to a machine which only understands lights on, lights off, right? So that's why we are doing encoding. So this was the same problem which scientists had faced when they were inventing this AI tool. And we saw a part of it. Like the problem was, how do we encode and tell the machine what we want it to do? And that's when we saw this whole idea of measuring the frequency of words in a given sentence. For example, if you're given a sentence which recites all the colors in the world, you are going to give it one column for color red, one column for blue, etc., etc. And you're saying one in the first sentence, red occurred only once. In the second sentence, blue occurred only once, but red occurred 0 times. So on and so forth. I'm saying the one is, assume the number one is one sentence and number two is another sentence. And this kind of encoding is known as one-hot encoding. In a way, this is what we first thought. Let's give all, how can we tell machines what we are speaking? And remember, this is not a basic transistor diode-based lights on, lights off machine. We have come like half a century ahead of it, and we are looking at an architecture called GPT, supposedly intelligent. So people were thinking, okay, how do we tell this to machines and machines like neural networks? And this is what somebody said, hey, what if we start with giving it the encoding of how many times does the word occur? So if the sentence was sun rises in the east, we will start encoding sun happens once, rises happens once, in the east, each of them happens once. And if you are using if your vocabulary contains the word west, you'll give it 0. In a way, we are telling the machine what is yes and what is no. But clearly, that was very primitive. Like this did not really help. So this is what people came up with later in 2013, actually, which is known as the whole concept of embeddings. What is embedding? Somebody discovered, this was from Stan inventor, discovered that there is a way of encoding where you can generate a huge vector, usually 256 or any other higher power of 2 from there, but a vector of length 256. And we start by giving each word in the dictionary a vector. And initially, these vectors are just randomly initialized. We give it like 0.1, 0.3. It's literally a random number generator, which sits and initializes it. But this was the first encoding we used to talk to GPT. And once we started training the GPT or any of the large language models or transformer-based models, we slowly noticed that the transformer was actually populating some values for each of these columns. It was learning something. Remember, our idea was earlier, there was this, if you remember from last classes, we were having feed forward and back propagation. So after that back and forth pass, people started noticing that, oh, it's populating parts of this encoding. And what does it mean, right? So the way people had thought of this encoding was they took one of the vectors for cat and plotted the vector on a graph, just like a vector a point. You can imagine the graph now is an arrow coming out of the screen for cat. Then they plotted the vector for kitten, and they realized, oh, the vector for kitten is very close to cat. Then they plotted dog, and they realized, oh, the dog is far away than cat. More importantly, when they plotted the vector of woman, man, king, and queen, they realized the angle between these two vectors, or in this case, the length, the Euclidean distance between these 2 points, between man and woman, is exactly the same between king and queen. And that's when people realized, oh, this machine is understanding something. In your mind, king and queen is a man and a woman. And if you think about it, they are kind of at the same distance, sure, at different contexts, but it is still a man who becomes a king and a woman who becomes queen as per the standard definitions of English and the English vocabulary. So when we started plotting this on like 2-dimensional graphs, that's when people started realizing, oh, here is a way we can embed meanings inside this large language models. We saw this last time, right? So once they had it, then the question was, still the performance was pretty bad. The model was not answering all the questions correct. So then somebody came up with this whole idea of attention. All right, what is attention? Let's see if you have attention now to reply to this question. What is attention? Guys online, can you unmute? I might and speak because I don't think I'm going to be tracking everything together. What do you think is attention? Are you attending a class now? Are you here? Are you awake? Okay, that's a reply which says active focus. Okay. So if you're in a class and if you're dreaming, are you attending? If you're sleeping, are you paying attention? No? So your consciousness is somewhere else. So when you wake up is when you have that consciousness or attention. Or attention is what your brain is currently focusing on. So people took the same idea and thought, what if, so remember what we are doing is essentially creating little machines that are similar to humans. And humans started thinking, wait, sure, I can teach a kid what is a cat, what is a kitten, but how do I make it tell it things like, oh, in this sentence, bank means financial institution, while in the another sentence, bank means a river bank. So people were thinking, how can we tell the machine that when the rest of the words around it is talking about cash, the word bank essentially there in that context means a financial institution. And for that, they came up with this idea known as attention matrix. This is the attention matrix of the same sentence. He later went to report Malaysia for 1 year. You can see that it's the same sentence plotted in x-axis and y-axis. And as expected, every word is giving highest attention to itself. Nothing surprising, right? Given report, let's say you tell this sentence to a child, he later went to report Malaysia for 1 year, and you ask the child, hey, I'm going to tell you the word Malaysia. You tell me what is the most important word in the given sentence when compared to Malaysia. And the kid is going to say, yeah, it's Malaysia, because you gave me Malaysia, and Malaysia is the other word which is more important to it. But as you can see in this graph, as the color gets darker, it's the highest importance. So Malaysia gives highest importance to Malaysia. And then it realizes, oh, we are talking about a report on Malaysia. A little bit importance for the subject, he, lighter colors for 1 year, one next. things like that. So you see how the meaning is slowly getting distilled into this idea, right? In fact, the more interesting thing was when we did translation of sentences. So do you guys know what United Nations are? What's the United Nations? Okay, so what is it? Okay. Nobody just know the word United Nations? Okay, global governing body. Yeah, I guess people are not trying to be diplomatically correct. Yeah, it's a global governing body, or more importantly, it is a collection of almost all the countries in the world. But the problem when such an entity was created, in fact, even in the League of Nations at 1944, was that all these countries in the world, they sent a representative, but then they realized this fundamental problem. Like, nobody speaks the other guy's language. Maybe I can speak English and Spanish, but that's it. How do I talk to the rest of the 150 countries in the world? So this was the very important, most important problem people were facing at that time. I'm talking about just after World War II. So then the solution was all of us, let's focus on one language, happens to be English, Queen's English. But even then, every language in the world needed a translator, a human translator. So if you look at UN proceedings, you can see that everyone is wearing a headset. And that's because they don't understand jack shit what the guy is speaking. Instead, there is another person from his country who is translating that language, whatever the language he's speaking, into whatever language he wants to hear. It's happening live. And I don't know if there are AI tools for that right now. I don't think AI is good for an audio signal yet. But every country in the world brings a translator minimally for English. So on the other hand, what people in AI world realized is that, and all these speeches have these translations, right? So, and they're all recorded. That's the law that every speech and discussion should be recorded. So 50 years later, in 2010, people realized, oh, wait, which means we have the world's biggest language to language translation corpus sitting in United Nations. Any sentence you take in one book in French, that sentence has an equivalent in English, right? Or you can go to the Spanish book of proceedings from that year and look at the same sentence, and it'll have a Spanish version of it. And remember, this is before Google. This happened before Google, where humans were writing all these translations. So all these people in AI world realized, wait, that is exactly what we're looking for to train AI. If I can take a sentence in French, which in this case is l'accord sur la zone économique européenne a été signé, and I'm butchering it clearly, but the translation of it is the agreement on the European Economic Area was signed in August 1992. When they gave this initially to the large language model, and we told them, go learn something, after all this feed forward and back propagation, the large language model came back and drew this chart for us, the alignment chart. Remember, it has no idea. It has never seen what economic is. It doesn't know what economic in French or Européenne. It doesn't know it's Européenne means European, economic means economic in English, right? Instead, just by looking at the context or the words around it, these transformer-based models were able to match that Européenne means European. See how smart that is? Like, the model had no idea what these sentences mean, but we gave them together, and all we gave the model was, here is a two-dimensional matrix, and here is an empty two-dimensional matrix. You add colors to it. The darker the color, in this case, the whiter the color, the highest importance this word on the left thinks is the word on the vertical axis is important. The machine says, hey, sure. Here, I think, okay, 1992, it's very confident it's 1992 in English. Août is August, and the machine correctly comes up with this matching. So how is it doing that? it's doing, if you remember, from context and exactly the same frequency idea which we had seen earlier. Given the word August, what are the other words that is occurring with it? Just by finding that frequency and doing this across all the documents from 1945, it was finally able to make connections like, oh, Août means August, or at least the machine doesn't understand. It showed this matrix back to the humans and said, oh, yeah, this is Août. Août is August. So now we have a well-formed machine which technically understands French to English or translates French to English. Or in other words, it now understands the encoding or how to encode French to English. So then people said, if we can make it encode, can we make it decode? So then we started giving it sentences which it had not seen before. Even some sentences about the events that happened yesterday, not what happened 50 years ago, which obviously was there in the corpus of training. But we asked it, hey, can you translate this event that happened yesterday? And it said, sure, I already have seen these words. Let me give you the corresponding French words for it. So that was a great invention of thinking of how humans give attention to everything. Without attention, we probably won't even be in this body, right? We might be an unconscious soul. So even that thought is translated into the AI world like this. In fact, there are visualizations where you can give two sentences and ask the model, which given sentence one and given sentence two, which word do you think is most important? In fact, if you go to this link here, there is something called as BirdWiz. It's an interactive tutorial. So you can either try loading it, or you can just scroll down and let's see this, right? So given sentence A and sentence B, this is the same sentence. The cat sat on the mat, the cat sat on the mat. Sure, it's thinking given cat, it thinks the is important, all right? Yeah, given sat, and it's almost like asking, okay, who sat? Cat sat. See, the cat has the highest degree, highest color, and let's say mat. Mat should be, I don't know, where? But this is again on the same sentence, right? That's not fun. Let's see something else. Let's see if they have sentence for different sentences. So this still has the cat sat, the mat, the cat lay on. Okay, maybe this one. So these are two sentences. The cat sat on the mat and the cat lay on the rug. So these are different layers. Remember, we were talking about the name deep learning comes because we have so deep layers of tons of neurons. And you can look, so usually in transformer-based models, there's like 12 layers, 0 to 11. And the last layer clearly is the one which has learned the most. And if you can ask the layer sentence A, if I tell you cat sat on the mat, which is the word that is most important, clearly it is giving you that the separation token is important. And this was a well-known issue in BERT, which people were trying to solve, because if you go to the initial ones, it could probably gives you other words, but eventually it was dumping everything on in the word separation. Long story short, attention works. In fact, Carlos just told me there's actually this visualization called babycroft.net, which helps you visualize how a large language model looks like, right? So if you go there, you're seeing, okay, let's start with GPT-2 small, and you can, of course, make it bigger. You can see these things. This is actually you see this transformer, like internally GPT uses transformer, and you can see the word attention. It's called self-attention. And you can see that if you open up this attention layer, here, let's see, there are all, it's nothing but just a matrix. They gives it matrix and matrix after matrix after matrix. Just give them the frame, give this matrix framework to the LLM, and the LLM fills it up for you based on two sentences. Let's look at it from top. So if you go to the introduction, I'm picking Nano GPT. Let's pick the latest GPT, right? Yep. Let's start small. Nano GPT. embeddings, right? So initially when this Nano GPT goes in, we remember the very first layer is embedding, which is nothing but you take the input, you take the output, which is, let's say, the translation. In English, you give it in French, give them both to the machine. The tokens are embedded, and they're also embedded based on the position on where is which is standing. See, the numbers are just encodings there. Then that is given to this next level, which is the layer norm, the normalization layer here, which remember, all of this is purely software. It's written in Python or C, if maybe C, because if you want it to compile close to the metal. And then this is the core working horse, the self-attention layer. The self-attention layer was nothing but a bunch of matrices where you decide, you as in the LLM decides if this is mapped to this word is important to that. Then everything else is more like bells and whistles. Projection is converting that to a different plane. MLP is multi-layer perceptron, or in short, this is the deep neural network, right? This, what you see here, is the deep neural network. And this is just one layer of it. You have the whole transformer layer after that. And softmax, if you remember this, takes that prediction, which tells you in this case, let's say we got the sentences mapped between English and French, but we still want it to predict the translation of a new sentence. Let's say we gave it a new sentence and it gave you the logits or just numbers. And the way you convert that logics is, we saw this in one of the earlier classes, we convert it in such a way that to find out which one of these classes the machine thinks is most important. Now, the interesting thing is the whole thing, this is just one cell of GPT. Let's click on GPT-3. As you can see, there are millions and millions of such cells all sitting next to each other across so many machines. So like I said, the sheer amount of resources needed to run this is unimaginable for a common man, which is why we need to have huge investors who invest on places like GPT, right? Layers and layers. In fact, data stores of big machines, racks, sometimes they're all sitting in the sea, in a ship in the sea, for two reasons. One, it's free cooling system. Your bottom is always wet. And two, laws. If you're on international waters, you don't have to follow the laws of any country. So people have been doing all these smart things with these server farms where all these machines are sitting. So chat, where's the question and where's the chat? No, all right. Lost it again. Got it. Why are there multiple matrices instead of one massive matrix in everything related, matrix with everything related in the attention? Yeah, so this whole idea is, remember, I'm giving one sentence, just two sentences in English and French. But if you limit the machine with just those two sentences, we are limiting its ability to visualize. We also take every sentence and map it with every other sentence. So not only is it for creating an attention map for the one sentence you saw, but now it's also, let's say there are 1 million sentences in English and 1 million in French, the equivalent one. So as you know, the sheer permutation or combination of that is 1 million times 1 million. So to accommodate that level of detail is why we need so many different metrics and so many different layers of it. Simply put, this is a huge beast. How it works, nobody knows, because we are dumping all this into these matrices and it is giving you all these nice vector kind of visualizations. But more importantly, the truth is we still don't know what is the meaning of attention in terms of human understanding. So for example, the word in this case, the machine says, oh, should a robot obey orders from humans? And robot gave attention to robot for sure. It gave 25% attention to obey, 10% to orders. Why? So there's no way for you to like understand this, which is of course the bane of current neural networks. Now, after doing all this, in fact, GPT is not just encoding. GPT does something known as encoding and decoding, which if you remember is encoding is simply creating that attention matrix. And decoding is, given the attention matrix, can you tell me something back in English? So people kept experimenting with this kind of stuff. Let's give encoding and decoding alone. And this was the very first thing people had tried. And then people started thinking, wait a second, what if we don't use encoding and we use only decoding? So then that became a decoder-only model. And in fact, the typical encoder-decoder use is sequence to sequence. But then you must be asking, right, wait, if you're not encoding something, how do you decode, or what are you giving it to the machines to learn from? Sure, in case of translations, we had the gold data with us already, which is here's the sentence in English, here's the sentence in French. You just find the relationship between these two in a mathematical plane. But think about this. We take all the reviews from Amazon and give it just the stars alone. And we are asking the machine, given this review, give me why people thought this was 5-star. So that's what we saw the problem of sentiment analysis. But the bigger problem was labeled data, like something which has a label to it, is only 1% of the data on the internet. Everything else on the internet is plain text. People just chatting things with chatting things with each other. So how do you amass the knowledge that is present in so much text? And that's where they came up with this whole idea, GPT. And this is the picture I showed you earlier. It says, okay, hold on. Even encoding all the sentences in the world on the internet is a gargantuan task. Why don't we use something known as auto-regression? And we already saw this last time. Do you guys remember this? Okay, let me move the chat window around. What does this do? Does anyone remember what does this do? Yes, it's predicting the next word. And then what do we do? It's okay, say it tells you, okay, you gave me my, and I'm telling you the answer is name. Now, what do you do next? Okay, here's candy for you for the last answer. Share. Sharing is good. Okay, so what we are doing is we ask it the first question, it gives the first answer. We take the first answer and make it the second question. And this technique is simply known as auto-regression. In a way, we are telling GPT, I am going to give you the entire text. You figure out which word comes after which one. In short, we told GPT, recite the first law, like after it was training, and we even gave it a robot may not blank, blank, blank. And GPT started replying with, hey, here's the next word that usually comes. Here's the third next word. That's it. The chat GPT you are looking at is nothing but a glorified prediction mechanism, which tells you which word has the highest probability of coming next to it. When people ask me, is chat GPT intelligent? I'm like, no, it's a glorified spitting mechanism. It's a llama which spits at you. It's spitting one word after the other, which it thinks is the best probability of the word to come after it. So same thing we saw, we take this sentence, break it down into encoding. Okay, in this case, we are not encoding, we give it to the embeddings and do only decoding. And in fact, we use something known as masking. We saw this also earlier. We mask one of the words in the sentence and ask GPT, hey, here is a sentence. A blank must obey the orders given it. And your choices are robot, human, dogs, and you tell me which one goes here. And GPT says, oh, you masked robot, but I know it's a robot because I've seen sentences like this before. And the way it does this is something known as byte pair encoding. Sorry, reminders. Okay, so maybe we are out of time today, but let me also show you some of the hands-on that you can play with today. If you go to DL workshops, so this is UA Data Lab, DL workshops, repositories, DL workshops, lecture 4. So this is the tutorial which I had shown you, the visualization one. Go to the V2 API access in OpenAI. And here we are going to learn how do you call GPT from your own little Python script. Click on Open in Colab as usual. I'm going to say File, New Notebook. We'll just do this before we break for the day. So I'm assuming all of you have an account in GPT. So go to OpenAI if not. OpenAI, log in, create an account, use whatever login you want. And then here, you can actually find your login and specific details about you. Go to settings, and we are looking for, you might have an organization, but more importantly, we are looking for, can't find it. All right, API keys. API keys. API keys is essentially unique, something which is given to every new user. And if you're new, you should have some sort of API key and a bunch of free credits. So let's go back here. Let's start with pip install OpenAI. Remember, we are not installing transformers this time because we are not going to play with transformers. We are going to play with a couple of generations later, which is ChatGPT, right? But from a command line. But also remember, the free version is pretty limited. Like, in fact, I don't even have, my tokens are completely exhausted. So you can only play with this for a limited time unless you want to start paying for it, which is, of course, why we created our own chatbot. All right, you need to install TikToken also. TikToken has got nothing to do with TikTok. It's a different tokenizer. And in fact, TikToken existed before TikTok became famous. And exactly what it does is, if you click on this, it just is like counts the number of words, right? A glorified token counter. And that's what we need next. Once you have that, the way you do this is import OS from OpenAI, import OpenAI. These guys are narcissists. So client is equal to OpenAI of, oh, it even shows me what the functions are. This is good predictive analysis on Colab. You have to give it first the API key. So go to your, if you already have an account, go here. Where is it? Secret key, click. Nope, edit. No, where is the damn secret? Okay, let's create a new secret key, right? Test, create secret key. All right, copy the secret key, bring it back here, and give it there. Okay. Let's run that. That's good. It understands the secret key. And next, chat_completion. So we are going to give, and this is the format in which you need to ask questions to ChatGPT. Completions.create. So client.chat.completions.create. You have a list of your own messages. It's a dictionary. It's a list of dictionary. And in the dictionary, you need to have role, which is the role you are, which is, this is boilerplate at this point. It's just, what is a role? Yeah, sure, you're a user. More importantly, content is what you're giving. The key content whose value is, say, this is a test, right? So this is done. And you also need to give it the model. All right, I think I messed up some bracket somewhere. 1, 2, 3. All right, model equals, okay, let's see. Let's see what models we have for API access, right? So playground. Oh, if you haven't gone there, you should go to the playground also and try playing with whatever models you can find here. You can pick all the latest GPT models and start playing with it. So let's see, let's give it like the state of the art, GPT-4 Turbo Dash Preview. Clearly, it's going to be paid. GPT-4 Dash Turbo Dash Preview. All right. And what else? We are done. Let's see. Chat completion syntax. All right. I'm just going to go back and paste it from the file which we had, because if I try to fix this bracket, it's going to take me a while. So let's go find the code, copy this, copy cell, go back here, paste. All right. Will it work? All right. So it's basically saying incorrect API key simply because my API key doesn't have any money left on it. So if you have an API key, and if you have just created an account, you can start your own chatbot and it'll start responding to this question, hey, where does the sun rise? So why are we doing it in command line when we can do it from chatbot, right? Remember the story, we can, as you know, you all can go to chat.openai.com and start talking to these models. But more importantly, if I want to fine tune an open AI-based model, you have to do it from command line. And clearly, their paid model is created in such a way that you have to start paying for things before you can do anything other than just chatting with your free chatbot, right? So which is why we just created our own chatbot where you bring your data, we customize it for you, and voila, you will have a chatbot talking to you. More importantly, since we are limited by the options GPT provides to access it from a command line, we are going to use Llama, which is an open source model which came from Meta. In fact, we'll use Llama. I want you guys to go there and download the model. It's going to ask you all these details if you haven't done it yet. It's usually faster to get if you use your U of A email ID, or even put like something university here, so you get this done faster. I also want you guys to go play around with something called as langchain.com. So remember, everything we are doing is on code. We are attaching, remember the pipeline of Hugging Face, right? So now LangChain, what it does is, it is its own pipeline, and they have given the instructions here, and we'll probably do this later in the course. It's going to show you, hey, here is the way you can combine all these models. So you don't really have to do anything except copy paste this thing. And remember, we were asking like, hey, topic, tell me a short joke about topic. But this is a little bit more glorified wrapper. And it tells you, hey, yeah, okay, you're going to chain it, literally LangChain. You're going to take the prompt, give it to the model, and the model is going to reply here. So yeah, just go read this, start playing around with LangChain, because that's where you should eventually end up at the end of this class. All right, that's all I have for today. If you have time, let's see if I can run by the slide deck. Okay, so talking about encoding, right? So remember I was saying tick token, it uses this technique known as byte pair encoding. And it's pretty simple. Remember when we started encoding, we said, hey, how many times does the word sun occur? How many times does the word rise occur? How many times does the word east occur, etc.? But people realized if you start giving it subwords like old, older, finest, you take them and you convert that into first, just the letter W, OLDER, then you slowly start combining the most frequently occurring bigram. The definition of bigram is 2 letters together, 3 letters together. And they kept doing this, and they realized like in English, there are some patterns which keep repeating even within the word EST. If you think about it, oldest, youngest, and all these things, but there's always an EST. So that's what people were telling the machine now. Don't just look at the word oldest, also give attention to the fact there's EST. This was another technique somebody thought, let me try it. And ta-da, we have GPT, right? So yeah, that's all it has. Fundamentally, the GPT, what it does is takes all these words, learns on everything under the sun, and you can fine tune your GPT for your own specific tasks. And in other words, for transferring this learning, if you hear zero-shot learning, transfer learning, meta learning, in-context learning, these are all like very related to each other. So sure, go home, play with the OpenAI API if you have tokens left in it, or download Llama, play with LangChain, because next week we are going to start looking at prompt engineering, prompt tuning, chaining, LangChaining, and fine-tuning GPT. I'm going to call it fine-tuning an open source large language model because fine-tuning GPT is expensive. All right. Thank you, guys, if you are still here. Thank you for listening. Go have fun with LangChain.